Good morning. The previous classes in physics, we have completed the third unit, that is called effects of current. Actually very big unit, and I have given the final steps. We have to keep your mind the final steps and substitute everything we can able to find out. Now we can pass on to the fourth unit topic, electromagnetic induction and alternating current. Another interesting and also very easy to understand and also very easy to keep your mind. So in this chapter we are going to see about electromagnetic induction, alternating current, what are its applications and the problem. So first we can have an introduction about electromagnetic induction. Induction, the word we are using from the first unit itself. What is induction? Generally, we can obtain charges without any contact. It is called induction. We know that charges are called induced charges. Study of induced charge is called induction. We know. Similarly, in this unit, what we are going to do? We have seen the induction stove, everything we know, but we don't know what is actually the principle. That is a problem. So have you seen the induction stove in our house? So on the top of the induction stove, if you are able to touch your hand, you won't feel any heat. But unfortunately, if any container is placed over it, automatically the liquid inside the container gets heated. How it is possible? So the heat is directly goes to the liquid without any contact. So that is called induction. So that stove is called as induction stove. Here electromagnetic induction, this was actually given by the scientist Michael Faraday. After this electromagnetic induction only, there is a revolution in the commercial power supply. So domestic power supply we know, commercial power supply, there is a revolution. Even though any power cut, we least bother about it. Immediately the generator is switched on. What happened? So we are utilizing the entire electromagnetic induction for that purpose. So the Faraday's invention was very much useful for the revolution of electromagnetic induction. That means commercial power supply. Then what is an electromagnetic induction? Whenever there is a change in magnetic flux linked with the coil, an EMF is produced or induced. So in order to get this actually a converse of third unit. In the third unit what happens? Whenever the current flowing through the wire or coil, magnetic field is produced. Reverse, if there is a change in magnetic field, electric field is produced. Just we can keep your mind. But one difference, if there is an electric field, automatically there is magnetic field. But even though here we are having electric field, we are not having magnetic field. Be careful. Even we are having magnetic field, we cannot obtain electric field. What is important condition? There is a change in magnetic flux. If you are having change in the magnetic flux linked with the coil, then only EMF can be induced. Then the laws. First law is called Faraday's law. Second law, Lenz's law. What is Faraday's and Lenz's law? The Faraday's law, very interesting thing. Faraday's actually formulated his law by two ways. The first law, whenever there is a change in magnetic flux linked with the coil, then EMF will be induced. The second law, the induced EMF is in such a way that there is a change in magnetic flux, that is d phi by dt, or phi 2 minus phi 1 by time. Phi 2 final flux, phi 1 initial flux, phi 2 minus phi 1 change in flux. change in flux by time will give EMF. That EMF is called induced EMF. So how it is possible? Whenever there is a change in magnetic flux, EMF is induced. In which way it is possible? He did so many demonstrations. We take a coil of wire. The coil of wire, if I connected a galvanometer. What is a galvanometer? Galvanometer is an instrument used to check whether the current is flowing or not. So through the galvanometer, if any current flows, automatically we can see the deflection of the needle, from which we can conclude that current is flowing through it. So just like that, simply he had one galvanometer in a particular coil. In this coil, he take a bar magnet facing north and the south pole. Just like that, this is a coil, my fingers are the coil, this pen is a magnet. The pen moves towards the coil. That means the magnet, the bar magnet, move towards the coil and away from it. Then there is a deflection in the galvanometer. What does it mean? Because of the movement of the magnet. Movement means we are changing the magnetic flux. If we are changing the magnetic flux, automatically current is produced or EMF is produced. This current is called induced current or induced EMF. The study of this induced EMF is called electromagnetic induction. So what happened here? So I keep the magnet, I keep the coil. If the coil is also moving towards the magnet or away from it, then it is possible. Whether magnet moves towards the coil or away from it, or coil is moving towards the magnet or away from it. Whatever may be the thing, we have to change the magnetic flux linked to the coil. Then only EMF is induced. If I take a coil, I place a magnet very close to the coil without any motion. We are not seeing any deflection. What does it mean? It means current may not be produced. What do you conclude from this? From which it is clear that whenever there is a change in magnetic flux linked to the coil, then only EMF can be obtained. So, this I have given in the charts, the slides. The magnitude of the induced EMF is equal to the rate of change of magnetic flux through the circuit. The lens modification, that is you have to understand it. Lens law more or less equal to that of Faraday's law. What is the difference? Here two things are happening. One, we are changing the magnetic flux. Due to the change in magnetic flux, the effect is EMF. So cause and effect, you have to keep your mind. Here what is cause? Change in magnetic flux is cause. Effect, induced EMF is effect. What he says, Lenz clearly says that this induced EMF is always in such a way that opposes the cause. That means if the direction, if magnetic flux linked with the coil changes, if the change in magnetic flux increases, we are getting a decreased EMF. If change in magnetic flux value smaller and smaller, we are getting more electric field. That is the thing. They are not in the same direction, but in the opposite. Therefore, the Lenz law from Faraday's law in which way? We know already E is equal to d phi by dt. This law is called Faraday's law. Instead of plus, if I put minus, that is d phi by dt. If I put minus, then it becomes Lenz law. What does it mean? Both are the same concept. Whenever there is a change in magnetic flux, EMF is induced. Okay. In other case, directly the induced EMF is not in the same phase but in the other. That means opposes the cause. That is called Lenz law. What does it mean? Magnetic flux linked with the coil, the change in magnetic flux more, EMF induced is less. If change in magnetic flux is less, automatically what happens? The growth, nothing. If the change in magnetic flux growth decreases, in this direction, therefore EMF increases. If the growth in the positive direction, the EMF, induced EMF is less. That is the thing. So that the Lenz law is a conservation of energy. Why it is called conservation of energy? So a lot of experimental fact also that Lenz law is a consequence of conservation of energy. What is conservation of energy? Energy can neither be created nor be destroyed. But we can convert one form of energy to the other. In which way here? Here we are actually moving the magnet. The motion of or moving the magnet is called mechanical work. Here the mechanical work produces the electrical energy. So this is a consequence of energy. So E is equal to minus d phi by dt. So just now we have it. What is called phi? Phi already told that it is a magnetic flux. Magnetic flux, in the previous lessons I have given the explanation and also definition. Magnetic flux, number of flux line crossing the entire area. Since mere number, it is a scalar quantity. How can you calculate the magnetic flux? Magnetic flux is nothing but B dot A, that is dot product of magnetic induction and the area. B dot A can be written as BA cos theta. So here we know EMF E is equal to d phi by dt. So I keep d by dt here. The phi value BA cos theta I goes capital N, nothing but number of turns. If there is a single coil, BA cos theta. If there are N turns, what happen? N into BA cos theta. Therefore, we can take N out, d by dt of BA cos theta. Very important formula. E is equal to minus N d by dt of BA cos theta, where phi is flux per unit turn. If the flux changes from phi 1 to phi 2 in time t, that means phi 2 final flux, phi 1 initial flux, change in flux phi 2 minus phi 1 by t. If there are n turns, multiplied by n, therefore induced EMF average value is minus n. This is called instantaneous value. This is the average value. So what is you understand from this? From it is clear that induced EMF is opposite direction. Therefore, E is equal to minus d phi by dt. Value of phi is equal to NBA cos theta. Substitute everything, minus n d by dt of BA cos theta. This is the introduction I want to discuss with you. For example, I have given the two examples in the slide. The first example, I get only one coil, single coil. The single coil under the galvanometer, a magnet is moving towards or away from it. The second case, there are two coils. From the coil 1, the galvanometer, coil 2, there is a battery. That means, what does it mean? If the switch is open and closed suddenly, what happens? If the switch is closed, the current is flowing through the coil 2. The coil 2 is always called secondary. This is called primary. So, otherwise, this is called primary coil, this is called secondary coil. Whatever may be the thing. Where the battery is there is called primary coil. So, in the primary coil, the battery connection is there. When the switch is on, the current flowing through the coil. And the switch is closed, the current is stopped. What does it mean? If it is switch is on suddenly, the current flows. Because of this magnetic field produced. The maximum magnetic field is there. If switch is off, what happens? Current closed. Therefore, the maximum magnetic field going on reduces. Not suddenly, it reduces step by step. When there is a change in magnetic flux, that induces a EMF in the secondary. Therefore, galvanometer in the nearest coil deflects. This is also possible. This is known as mutual induction. Then we can explain our thing about here. What is the EMF? Induced EMF. This EMF can be induced. How the induced EMF possible? The EMF can be induced by three ways, because we know E is equal to minus N d by dt of BA cos theta. Just now I have said. So there are three ways. Number one is by changing B. So the magnetic EMF or EMF can be induced by changing B. So if you are changing B means other parameters, what are they? A and theta may be constant. Then what happens? Then E is equal to minus N. I take A cos theta out. This B d by dt. This is the first way. So if you are changing the magnetic field or magnetic induction, we can induce the EMF or we can obtain the EMF. Therefore, EMF can be induced by changing the magnetic field. How it is possible? This is achieved. How it is achieved or possible? This can be achieved by moving a magnet towards the coil or away from it, and also coil is moving towards the magnet or away from it. Whatever may be the thing. If you are moving means we are changing. If you are changing the magnetic field, automatically EMF can be induced. This is the first method. The second method, by changing area enclosed by the coil. Be careful. Area means not open area. The area enclosed by the coil may be changed. What happened here? Here also I consider two parallel wires. This may be considered like that by a constant wire. If there is another wire is there connecting these two wires, this is the area now. This is the area. Now this constant wire may be slide over these two. If I move this distance dx, therefore the new area becomes the entire thing. So now we are changing the area, automatically EMF can be induced. Here also E is equal to minus N B cos theta we can take out, simply dA by dt. dA by dt means change in area. So here number of turns only one. The magnetic field constant, we least bother about it. Cos theta, here two parallel wires. So we reduce to 0, cos 0 becomes 1. Therefore simply dA by dt. So if the length of the conductor is L, breadth is S, what is the area now? L into dx is the area. Are you able to follow what I say? Because it is a rectangle, the length and distance, it is moved. The new area, therefore L into dx. The change in radii is nothing but change in distance divided by time. Therefore L dx by dt. We know dx by dt is nothing but velocity, that is L into v. Okay. Now n, we are not having n, cos theta become 1, change in area is L into v, substitute this, we can able to E is equal to minus BLV. So this is the EMF induced when you are changing the area. Why it comes velocity? This lot of problem comes in the wings of the aeroplane. The distance between the two wings given means the value L is given. The more speed of the aeroplane, that is called V. If we are knowing V, L and V, we have to multiply all the three. Automatically we are getting the EMF. That is also possible. You have to understand it. E is equal to minus BLV. So this is the given in the formula. If R is the resistance of the loop, then induced current. Once we know EMF is BLV, the current may be, we know V is equal to IR, I is equal to V by R, therefore BLV by R. The current also calculated. The direction of induced current can be found by Fleming's right hand rule. So be careful in the up to third unit, that is electromagnetic effect. We have to use the Fleming's left hand rule. Here the direction can be obtained by Fleming's right hand rule. Already we discussed that the forefinger and a middle finger and a thumb are mutually perpendicular to each other. The same thing, the forefinger gives the direction of B, magnetic induction. Thumb, the motion of the conductor, that means velocity or force. The center finger gives the direction of current. So here current is induced. What is the direction of the current? The middle finger points where? That is the direction of induced current. How can you calculate the current? Induced EMF or current, both are same. Induced EMF can be divided by the resistance, that will give the current. Current will flow anti-clockwise. So this example I have given, that is C, D, E and F, electric field and force. So G and H. Here F1, F2, F3, and this is direction, motion of the body in this direction. This is placed in the magnetic field of induction B. Here F2 and F4 are equal forces but in the opposite direction. Therefore cancels out. To act on 3 arms CD, CG and DH. F2 and F3 being equal and opposite, hence cancels out. F1 is given by, we already know, charged conductor moving in a magnetic field experiences a force BIL sin theta. Here theta is equal to 90, therefore BIL. So that is equal to, F1 is given as BIL. What is the value of I value? Just now we have seen BLV by R. Therefore B squared I squared V by R. How this comes? We know the induced EMF is BLV. Therefore induced current is BLV by R. So instead of I put this. Therefore B into B, B squared, L into L squared, V by R. The power required to pull the loop. Power we already discussed in different way. Even in the first year, the power can be calculated by force into velocity. That will give power. Why? Because we have discussed in the previous lessons, force, that power is nothing but rate of doing work. Work done by time is called power. Work done is nothing but force into displacement by time. Displacement time will give velocity. Therefore, power can also be found out by using force into velocity. Therefore, the force we have calculated as that value into V. Therefore, V squared, L squared, V squared by R. So that is a thing we have to understand it. That is a value I have to put. Here, I value won't come because instead of I only BLV by R. So here L already L. Therefore L squared. This is nothing but L squared. Actually this formula is B squared, L squared, V squared by R. The rate at which the joule heat produced. We know detailedly we have seen in the previous lesson H is equal to I squared R. Therefore H is equal to I squared R, B squared, I squared, V squared by R. This is the value of amount of heat produced. Because F into V is called power. Power is also known as I squared R. We know power in the previous lesson, I squared R also power, V squared by R also power. You know everything in the previous lesson we have seen. So power is equal to I squared R. So I squared R is the value. Therefore V squared by R is called also power. So H is equal to I squared R. Therefore I squared R value nothing but power. This power value this that can be substituted. These are the relation between amount of heat produced as well as the induced EMF in. This is the central syllabus. Be careful. In our syllabus, we have explained up to induced EMF E with the change in area. That's all we have seen. But here, we have additional point. That is a thing we have to understand it. Production of induced EMF in a coil by rotating it in a magnetic field. So this is another thing I have to understand it. The first one, change in magnetic flux. Second one, change in area. The third one, orientation of the coil. Orientation. If the orientation of the coil changes, that means theta. Because we know E is equal to minus N B A d by dt of cos theta. So we have to have a orientation. Here, angular velocity, because it rotates, omega is equal to theta by t, or theta is equal to omega t. Therefore, minus N B A d by dt of cos omega t. We know it is a function of function rule. We have to differentiate it. Minus N B A d by dt of cos theta minus sin theta. Therefore, minus sin omega t into omega. This minus and minus become plus. Therefore, N B A omega sin omega t. So this is the EMF induced. Or E is equal to, this value can be modified as E naught sin omega t. E is equal to E naught sin omega t. Such a EMF is induced when you are changing the angle of orientation. What is the meaning of angle of orientation? We are taking the coil. Whatever be the coil, this coil is just like that, placed inside a magnetic field. So suppose it turns, the coil turns through an angle theta. Initially, the angle is 0 angle. If it turns, what happen? 90. Again it turns 180. Again it turns 270. Again it turns 360. Like that the coil continuously rotating. If continuously it rotates, what happen? Angle continuously changes. If angle continuously changes, what happen? EMF can be induced. So EMF can be induced in such a way that changing the angle of orientation. So automatically we are getting E is equal to E naught sin omega t. What is E naught? E naught is called peak value or maximum value of EMF. Therefore, E is equal to E naught sin omega t. These are the three ways for the orientation changes.